All right, today we are jumping into one of the coolest processes in all of evolution. It's like a creative explosion of life. And it all kicks off with a puzzle that even stumped the great Charles Darwin. So, to get to the bottom of this, we've got to go back in time. Picture it. You're with Charles Darwin on his famous voyage, and you land on the Galapagos Islands. It's this remote volcanic place, and it's right here that the first little seeds of a totally revolutionary idea start to grow. So, Darwin's looking around, and yeah, there's all sorts of amazing wildlife. But the thing that really grabbed his attention was a bunch of, kind of plain looking little black birds. They seemed to be everywhere he looked. But here's the thing, they weren't all identical. Not by a long shot. The sheer variety just blew him away. And that's what sparked the big question, right? He's thinking, okay, these are all definitely finches, but they're all so different from each other. So how on earth could one tiny, isolated spot in the middle of nowhere produce this incredible rainbow of variations, all from what seemed to be one type of bird? That's the puzzle we're going to solve together. Well, the answer to Darwin's whole finch puzzle is this really powerful idea in evolution. It's the how-to guide for the way a single ancestor can just explode into all these different forms, creating this incredible diversity, and sometimes in a surprisingly short amount of time. And that concept is called adaptive radiation. You know, the name itself kind of gives you all the clues you need. You've got a single ancestral stock happening in a specific geographical area, and then they're radiating out. I like to think of it like tossing a rock into a pond. You see those ripples spreading out in every direction? That's basically what's happening here. So if you boil it all down, the key phrase to remember is this: one source leads to many forms. It's that simple. You start with one original group, and then boom, over time, it just branches out into all these different versions of itself to handle whatever the environment throws at it. Okay, so let's circle back to those finches and see how this works in real life. Step 1, a little group of the original seed-eating finches shows up on the islands. Step 2, the radiation part, their population grows and spreads out all over the place into all these different little habitats. Then step 3 is where the magic happens, adaptation. Some finches start eating insects, others find new kinds of seeds or flowers. And what happens? Their beaks literally change shape to get better at eating their new favorite food. And finally, step 4, speciation. After enough time, those changes become so significant that, poof, you've got brand new, totally distinct species of finch. Now, Darwin's finches are like the classic textbook example, for sure. But if you really want to see the mind-blowing power of adaptive radiation, we need to think bigger, way bigger. We're going to scale up from a tiny group of islands to an entire continent. Yep, we're heading down under to Australia. So think about it. Just like the Galapagos, Australia was totally isolated for millions of years, and at some point, a single ancestral group of marsupials got there and basically found a wide-open continent. It was full of what biologists call niches. You can think of them like available jobs in an ecosystem. And the best part? Almost no competition. And the result of that? An absolutely incredible explosion of different animal forms, all from that one starting point. I mean, just think about it for a second. You get a kangaroo that hops around and grazes, a koala that just chills and eats leaves, and a wombat that burrows underground. They couldn't be more different, right? But they all trace back to that same common marsupial ancestor. That is adaptive radiation on a massive continental scale. Okay, so one species can become many. We've got that down. But this is where the story takes a really fascinating, kind of weird twist. What do you think happens when this whole adaptive radiation thing happens not just once, but twice in two completely separate, isolated parts of the world? Well, the answer has a name. It's called Convergent Evolution. And it's what happens when evolution is faced with the exact same problem in two different places. Let's say you need an animal that can burrow, or a really fast hunter. Evolution in both places can come up with shockingly similar solutions, even though it's starting with totally different blueprints. So basically, we have these two massive evolutionary experiments running at the same time, but completely separate from each other. On one side, you have the marsupials doing their adaptive radiation thing down in Australia, and on the other side, you've got the placental mammals, that's things like us, dogs, whales, bats, doing the exact same thing all over the rest of the world. And what you get is, you get evolution's doppelgangers. It's wild. The rest of the world had an opening for a fast, four-legged hunter, right? And the placental mammals came up with the wolf. Meanwhile, down in Australia, the marsupial line had the same job opening, and it came up with the Tasmanian wolf. They look so much alike. But here's the kicker. They are not closely related at all. It's the same thing with the anteater and the numbat. Completely different evolutionary paths, but because the job was the same, the result is uncannily similar. So, okay, we've gone from tiny finches on an island all the way to these continental lookalikes. What's the big picture here? Why should you care about any of this? Here's the most important takeaway. Evolution isn't some straight line marching toward a perfect final goal. Not at all. It's a messy, creative, super adaptive process that just works with whatever it's got wherever it is. It's all about solving problems and filling those open jobs in an ecosystem. And what's really cool is that sometimes the best solution to a problem is just so good, so effective, that evolution stumbles upon it more than once from totally different starting points. And that leads to one last really big question to leave you with. After seeing how convergent evolution works, you have to wonder, right? If we could somehow rewind the entire tape of life on Earth and just press play again, would we end up with the same kinds of animals? Would we still get something that looks like a wolf or a kangaroo? Or would life go down a completely different path, creating things we can't even imagine? It's a fun one to think about.